Three physics professors made an incredible discovery that could save lives and drive yet another computing revolution. They just won the Nobel Prize for Physics for capturing and tracking the movements of electrons in ways that you may not believe. Craig Patrick is here to explain.
Well, keep in mind the micro-universe, the world of electrons flying around within atoms have really been a blur, of course, to scientists, all of us, and that's limited our understanding of how and why they behave as they do. But that just changed. Now, this is complicated, but here's an analogy that may kind of put it in context, because I want you to think of a hummingbird. Its wings flap so quickly, it just looks like a blur to the naked eye, right? And to most cameras, and it takes a really fast or high shutter speed to be able to see what its wings actually look like when they are in motion, which then helps us better understand hummingbirds. Well, that's the analogy. The same idea applies to understanding electrons, which of course we cannot see with the naked eye, but we know what they do. For example, you see it here when charged electrons from the sun are caught in our atmosphere, it produces the northern lights. But electrons do so much more than this because they're the workhorses of everything, of chemical reactions, of how stuff holds together, how it falls apart, and how our bodies function or fail. But of course, they're so small and move so fast, the scientists have not been able to focus in and lock into them. And we're talking about something extraordinarily small within an atom that travels at speeds of 43 miles per second. But the Nobel Prize winners figured out how to capture those movements by using short pulses of light, sort of like putting a strobe light into a moving fan, but on a ridiculously faster scale of attoseconds. And that's 1/quintillionth of a second. For context, under Big Bang science, our universe is 13.8 billion years old, so that would mean there are as many attoseconds within 1 second as there are seconds in the history of the universe, and the Nobel physics winners figured out how to capture an electron within 1 attosecond. And why is that important? Well, it can help us drive new breakthroughs in a couple of ways. First, the ability to measure electrons in this way can help us detect very minute changes in people's blood samples, which can detect some serious diseases long before any symptoms appear.
That's a big advantage because this means that you have a sensitive method that can detect the disease at a very early stage, for example, lung cancer.
Yeah, for example, lung cancer, other different types of cancer, before it otherwise becomes detectable. That means molecular fingerprinting is what they call it, could find previously undetectable cancer that we could then nip in the bud before it spreads beyond the confines of an atom. And that's just one example. It can also improve, if not revolutionize, how we transmit electricity to make it far more efficient, and design smartphones that are far more powerful and efficient, and effective batteries for gadgets, and of course electric cars and homes. Those are just examples, and that's really just the start. And by the way, those three Nobel winners are Ferenc Krauss in Germany, and Lear in Sweden, and Pierre Agostini, Professor Emeritus in the United States at Ohio State University. Big day for Ohio State. And of course, this follows last year's Nobel Prize winner, John Clauser from California. And he discovered that light behaves differently based on whether or not we're observing the light. And observing one photon instantly alters its partner photon, even if it's on the other side of the universe. Some striking discoveries, weird discoveries that have incredible applications.
Wow, to think, I mean, there's so much there. But I just narrowed in on to think you could discover cancer before it, ever became a problem. That's just life-changing. Taking all those discoveries together, Craig, where could that lead, and how else could we gain from it?
Well, a lot of different things. Taken all together, it could challenge what reality even is and how we perceive it, which could help us solve the mysteries of existence. But applying it, I think to your question, more to everyday life, it's something that could drive also beyond the medical breakthroughs, huge leaps in digital encryption and also in quantum computing, making our devices so much more faster and far more powerful than they currently are.
Wow. Well, congratulations to them. That is a lot. Craig Patrick, thank you.